Hello guys, welcome back to my YouTube channel. Please like this video, subscribe to my YouTube channel, and share this content with your colleagues. In this video, we're going to look at a way in which we can represent geographical features. So we can represent these geographical features using two models, namely vector data model and raster data model. First of all, we are going to look at raster data model. Raster data model represents geographic features as a grid of cells or pixels. So each of these grid cells contain an attribute continuous number. This attribute continuous number can represent height, it can represent texture, it can represent color, and so on. Raster data model is suitable for representing continuous phenomena such as elevation, temperature, like I said, color, and whatnot. Open here is my Golden Surfer 11 window. I would recommend you use the same software. So this software will help us come up with the most accurate representation of a digital elevation model, which is one of the phenomena used to represent raster data model. So this digital elevation model is just a representation of how heights are distributed along a terrain of a piece of land on the Earth's surface. So to ensure that we represent the most accurate data on how these heights are distributed across a piece of land, we need to know what kind of data we know with respect to that kind of land. So we need to know if we have any information like the survey diagram. Do we have any coordinates of the boundary? We need to know if there's any title attached to this piece of land. Once that is noted, we need to collect more data. We need to collect more data of heights across this piece of land at every point. At every point, we need to make sure that we collect data of height, of course at specific intervals. But how are we going to collect that data? So say this is our area of interest. Of course, after doing your reconnaissance, you know what data you have. Maybe you have the survey diagram, which will give you the coordinates of this point, that point, that point, that point. Then all you know is that you need to collect the data of the height data of different points along this property, in this boundary. You collect height data on that point, on that point, on that point, on that point. But how are you going to do that? For a more accurate representation, you can collect this data using a differential GPS. But for a less accurate representation, you can collect this data using Google Earth, where you just pick points along your property, along the stretch of your property. Then for hills, you have to pick your points as you go up the hill. Pick your points as you go up the hill. Then you pick the rest of your points. Of course, you need to define your boundary first. You pick the coordinates of your boundary. After picking, then you continue with the rest. So your differential GPS, to set up your differential GPS, you will need to know your control point. So once you know your control point, you set your base somewhere, you reset at your control point, then you check at another known point. Preferably this point should be near the area of interest for a more accurate data output. So once you reset your machine at a known point, then you can start collecting your data with your rover. You collect this point, you collect this point. Of course, the rover will give you data of X, Y, and Z, which is a northing, south, northings, eastings, and heights. But in this case, you are interested in the heights, so you keep collecting the data, you keep collecting the data, you collect the data, you collect the data, you keep collecting the data. When you're done collecting the data, then you have to input your data. You have to organize your data properly using Microsoft Excel. So of course, you have to ID your points. You ID every point, you ID every point. You give a unique ID to the points that you collected on hilly areas, just for, you keep collecting, you keep collecting, you keep collecting. Just ensure that your data is well arranged. So these are my points. These are the points I collected of my area. These are just some of the points. Make sure that you save this in CSV. As you are saving, say I want to save this. So your data output should be in CSV, which is comma delimited. These are your data outputs, but our output in this video should be CSV. Make sure your output is CSV. Since I already saved it, I'll just replace it. Okay, once you have this data properly arranged, as you saw here, so we have our eastings, northings, then we have our elevations here. Then on the beginning here, we have the IDs. So you have to arrange them in this order. Once you have this data, go back to your server. So now we have to export that CSV file that we just saved in Excel. So to do that, we go on grid, then we click on data, then we click on the particular CSV file that we just saved. As you can see here, type, it says Microsoft Excel, comma, separated value, which is just CSV. Click on it, then you say open, then you make a few changes, because as you noticed, our first column in our Excel here, our first column has the IDs. We don't need these IDs, we need this, we need this, we need this. So there we're going to say column B, column C, then column D. So I'm going to say column B, column C, then column D. Then we're going to say, okay, since I already worked on this, I already have this file, I'll just replace it. But normally, if I hadn't worked on this, it wouldn't have brought this. So I'll just say yes. So here, after our data has been exported, after our data has been imported, the output will be this text file. So this text file contains some of the information related to the data that we just imported. So as you can see there, we have the median, the mean, we have all that data. So what we do is we just save this. I already had this, so I'll just save it, say yes, just replace it. Then we can just cancel it. Once we have that, now the software will help us come up with these outputs here. We have the new it will help us come up with a contour map. It will help us come up with a new post map, new classed post map, new image map, a new shaded relief map. So this software will come up with this software is going to help us come up with 1, 2, 3, 4, 5 outputs. So now we have our new contour map. So a contour map will just be a form of raster data, not a raster. It's going to be a vector data model. So this is going to be a vector data model in a way that it's going to represent this particular area of interest as discrete points, lines, and polygons with contours. So I'll just click on that. I want to create a contour map. Click on that and say open. So this is my contour map, which is just a vector data model. As you can see, we have polygons, lines, and points. Then we have our contours there. These are contour lines, which are lines connecting places with the same height. As you can see here, so these points were collected in a circular way to represent a hill or a hilly area. So this is our map here. We can edit or analyze this data more. So what can we do here? What can we add? What can we add? We can add a scale bar in case we want to locate this. Then we can say levels. We can say levels. Of course, our maximum contours. at 1295. Then our minimum, this is a minimum, then our maximum is 1306. Then the contour interval is 0.5, which you can change depending on the requirements of the job. Then if you want to make sure that contours, sort of adding context to the data here. So when this context is added to the data, the context of color. So when the colors are added, it now goes from a vector data model to a raster data model. It sort of becomes a combination of the two. So here, the color coding simply represents, let's add our color scale here. So the darker colors are representing areas of a lower height. Then as the color code keeps on intensifying, we see that the heights also keep increasing. So the areas with the brighter color or a brighter gray have a higher height. They have higher heights distributed all over them. So this is our data. So we can also, let's see another way in which we can represent these heights. So let's try to see a watershed map. How is a watershed map going to come out so that we can analyze more raster data models? So this happens to be our watershed map. How can we analyze this data? Remember, we all have different ways of doing things. I might have a different analysis, you might have a different one. This is what's so amazing about this. So I don't have much. So we still have the same data here, the minimum contours, the maximum contour, the interval level is still the same. Okay, it's not the same, so we have to click on this particular map that we've opened. I clicked on this one, that's why we didn't have this different data. Now that I've clicked on this, we have different data here. So this is the attribute data which is associated to this. So we can play with the opacity here. Okay, let's close this. Let's try to look at another output. Let's try to look at a more user-friendly attribute. Let's look at the 3D output, which will help us analyze this data. So this is the 3D output. So as you can see, This is the hilly area. This is the hilly area. Just picking heights along the hill would give an output like this. So as you can see, this place should also be hilly. Then these places, this area over here has a more lower height as compared to this point. So let's look at the properties here. So these are the properties we have. And we can sort of manipulate this data. So we can manipulate this data according to the way you want it to come out. So let's try to open another output so that we can see a different way in which we can represent this particular piece of land. Let me just close all these and open a new one. Let me open this, so it's 3D surface. So this is our 3D surface. So this 3D surface has these properties. So these are the properties. So you can play around with the colors. You can play around with the opacity. You have the minimum contour, the maximum contour. In case you need this data, you can just collect it from here. In case you want to show your base, you can just click on that. Your base is there. In case you need to show your scale, because the scale is very important for you can also switch on your map scale. Of course, it's not positioned well. You can just do that. So according to our color scale here, our heights are distributed differently according to the color codes. So we have the first color down there representing a height of 1296. Then we have blue there up here representing a height of 1305. So this data will just help civil engineers come up with a profile of a piece of land, which will eventually help in determining the cut and fill of earthworks. This will help in cost estimation. It really helps in coming up with a more accurate view of quantity. So let's look at another output. Let's look at another output. Let's look at a vector map, a grid vector map. So this vector map is another example of vector data model. As so this vector data model, as you can see, just number of lines. We just have lines in this one, but vector data model represents geographic features as discrete points, lines, and polygons. So this is just a vector, how a vector model would look like. What data do we have on this? We have the symbols of our arrows. So maybe we can try to manipulate this and just, let's say, change this to that. Let's see if it okay. Scaling, what else can we manipulate in this? Of course, you have the mix, minimum, maximum. You have others. Please don't mind my English sometimes. I'm not English, I'm Zambian. Okay, let's try to open another output. Let's try to see a different way in which we can model this. Okay, let's try this. So this is a shaded relief pattern. Of course, this is a raster data model. Because it's representing the relief of this area using a distribution of grids and cells. Okay, trying to see if we can add more context to this. Shading methods. Okay, let's close this. Let's try to look at another output. Let's try to look at the last output, then we can close. Let's try to see the new image map. Let's see how it comes out. So this new image map output. This is also a raster data model. Let's try to look at let's try to open one that is more contextual. Let's open this one in 3D so that we can see a way in which we can print this out. So we have your scale there. Show your base like that. And in case you need to practice, I will attach the Excel file. I'm going to attach the Excel file to this video. I'm going to put a link in the comment section. This link will take you to my Google Drive where you'll be able to access this Excel document, which was saved in CSV. So we can play around the colors there. Whatever gives a better context to your data is preferable in this case. So you're free to use whatever pleases you. So in my case, we're going to use this. We use this color scale. So you can edit your base, color of your base. So it can be blue. Nah, I don't like blue. It's too light. Let's try to use a more aesthetic color. Okay. Okay, no. But this will mess with our color scale. So we need to change it, edit base color to something darker, something like this here. Yes. So now, once you have something like this, in case you need to save this, you can save this. So this is the output, which is Cepha srf. So we can save this as tutorial 5. Well, you can choose a name for it, but I've chosen tutorial 5 for a reason, for better access, of course. Let's see how we can export this data. Is there any way of exporting this data as a picture? Let's find a way of. If we save, maybe we can change our output here. Maybe we print it out. Okay, let's try to find it. So it's in surfer data. Let me just search for it. Okay, surfer data. No, surfer works. Surfer works. Yes. So we can open it. Let's try to save it again. Just deleted the other one. Let me see if I can. Let's try to resave. So Microsoft, so then we say fetch to page. I say okay. So name it as PDF. Let's try to find it. Voila! So this is our presentation here. You can print this out and give it to your colleagues with whom you're working with and analyzing whatever data you have on this for better analysis and better visualization. We can use this. Okay, so thank you so much for watching. Please follow, subscribe, and like. For more questions, you can contact me on my WhatsApp number. You can drop a comment and what's and everything so that we can have a conversation. Thank you so much. Goodbye.